Welcome back, and we are talking domain and range today. Specifically, just domain and range on graphs and tables and mapping and stuff like that. So, before we can get started on that, though, there are a few vocab words that I want to make sure that you understand. That way, when I start saying it, you get what I'm saying to you. All right. So, first word is discrete. Okay. Discrete, another way to think of discrete is like it ends, it's not connected. Okay. It has dots or have dots in the graph. Okay. Versus continuous are lines or curves where those dots or those points are connected. So that's the difference, is like you played connect the dots, that's what made it continuous. You didn't connect the dots, that's what made it discrete. Having arrows on the end of your lines does not make it continuous. So don't get that confused. The arrows don't mean continuous. Okay. All right. Domain. Domain represents all of the inputs. Okay. So remember, inputs are the X values. And then another word that we're going to use is the X values, or the inputs, are also known as our independent values. Okay, they are independent. They do not depend on anything. Okay. When you are finding domain and range, you are looking left to right. Because remember, on a graph, the x-axis is right here, and its numbers run left to right. So when we state our domain and range, it goes left to right. Okay. The range is kind of the opposite of this. It represents all of the outputs. Okay. And the outputs are the Y values, and new word, the dependent values. Tomorrow we're going to talk, well, not tomorrow, actually, later, whenever you watch the next video, we're going to talk about reasonable domain and range, which is like word problems. And we're going to talk a lot about independent and dependent, because that comes into play a lot when we're talking about word problems. Okay. So when you are looking for your range, since it's the Y values of the graph, you look down to up, or bottom to top. Okay. All right. So we're going to look at a couple of these, and it's going to kind of go in a pattern, like I'm going to try one, you're going to try one, so on, so on, so on. Okay. So first one, we're looking at this graph, and we need to determine, is this graph discrete or continuous? And you'll notice that these are not dots, right? That clearly all the points that made this have been connected by a line or a curve. So this is continuous. Okay. So now when we are looking at our X values, or our domain, so our domain is our X values. Remember, I'm going to look left to right. So I'm physically on my graph going to put a mark where the graph stops left and the right. Okay. And so the easiest thing to do is to first state your domain in words. So my X values are between 0, and if this is 8, this is 9, right? So in between 0 and 9. So then the next thing that we have to do is we have to write it in math symbols, okay? And so we learned about compound inequalities the other week, okay? And we are going to put those to play right here. So our x value is between 0 and 9. So notice how I did that. It goes least to greatest, x is between them, right? And I told you guys about this in class, but your inequality should always, if there was like an arrow attached, like if I had a little arrow, pretend like that's an arrow, it should always point to the left. And since there's no open circles, I'm going to assume that everything is equal to. So x is greater than or equal to 0, and x is less than or equal to 9. Okay. Then we're going to talk about range. Remember, range is the y values. So I'm going to find the lowest point, which looks like it's right there, and the highest point, which looks like it's right there. And I'm going to have to kind of estimate this, it looks like. So this was -1, -2, -3 would be down there. So I'm going to call that -2.5. And this is at 3. So my range in words is in between -2.5 and 3. Okay? And so then we do the same thing that we did up there, except it's the y values. So my y goes in between -2.5 and 3. Again, making sure it goes least to greatest. Little part is to the left and with an equal bar. Okay? And then our last one, we just talked about this in our previous video. Is it a function? You could do the vertical line test on this if you wanted. Okay, I keep doing it. Is it ever going to intersect it more than once? Doesn't look like it. So is it a function? Yes. But remember, you can't say yes because it passes the vertical line test. You need to say yes. Every x value has only one y value. Okay. All right. So you guys are going to try the next one. Okay. So take your time. I'll go down so you guys can see all the numbers and stuff. Okay. And if you weren't able to print this out, that's okay. Just kind of try to draw a rough sketch of this on your paper so that you at least have it. Making sure that you have like the numbers and the peaks and stuff like that. But try to draw a rough sketch if you weren't able to print it. Okay, so answer your questions, and then we'll see you back in a sec. All right, so hopefully on this you said it was continuous because again, I don't see dots. I see a line or a curve. The domain, so looking left to right, those are my end caps, right? So in words, it would be between 0 and 21. So my x would go between 0 and 21, least to greatest. Little part facing the left. Okay. My range or my y values, so my lowest looks like it's at 0, and then this is the tippy top of it, which was at 120. I just crossed it out trying to draw that. So in words, it's between 0 and 120. And so mathematically, the y is between 0 and 120. Little part to the left with the equal bar. And then, is it a function? We do the vertical line test. We see that yes, every x value has, sorry, you're not going to be able to see that now, has only one y value. Okay. Okay, so now we're going to look at one that's a little different. Oops, forgot it's on the back, printed it. All right. So this looks familiar. We talked about this when we were talking about, like, is it a function or not a function, okay? But starting us off, discrete or continuous. We finally have a discrete graph, right? Okay, we finally have a discrete graph. And so that changes things for our domain and our range. Because it's not flowing, and like on these ones, we said it was 0 through 9 because it literally went all the way from 0 to 9. It covered every single x value, every decimal, every fraction in between 0 and 9, right? Well, when you have a discrete problem, that is not the case. So when you have a discrete graph, you list the domain and range. And you want to make sure that you list it in numerical order. Okay, pull it back up a little bit. Sorry, you guys can't see that. In numerical order, which means least to greatest. Okay, so we don't need to describe this in words because our description in words is going to turn out to be just like our math, okay? So how you do it is, it's kind of like a bracket, but it's like a squiggly bracket. If you can't do it, don't worry. Just don't use parentheses. Parentheses would be like an ordered pair, so you don't want to use parentheses. You want to try and make that squiggly. Looks like that, okay? Squiggly. All right, and then you literally just look at every ordered pair from left to right. So this ordered pair is at -3. This ordered pair is at -1. This ordered pair is at 1. This is at 2. And then we have 2 at 3. But the good news is that we only have to list 3 one time, okay? Because even if we listed it twice, it's not needed. 3 being in the domain is clear when we list it one time. So now that I've identified these are my x values, I just list it. So -3, -1, 1, 2, 3. Okay? So remember, you want to look left to right when you're listing that. Okay? When we do it for the range, you want to go bottom to top. Okay, so same thing. I'm going to look at these. So this is at -4. This is at -3. This is at 1, 2, 4, and 5. Okay, oops. There we go. And so now, squiggly little bracket thing, I list them least to greatest. So -4, -3, 1, 2, 4, 5. So again, the reason why we can't use inequalities there is because it's not covering everything in between. Like if I said that it was between -3 and -1, these aren't connected. So there's no part of the graph is between -3 and 1. It's only at -3 and at -1. Okay? Okay. So we are going to look at a couple more because these ones have arrows and that slightly changes things. Okay? So for my domain, remember, that's my left to right. Okay? Here's my furthest left. It's at -2. And then I see to the right that it's continuing forever, which means that this only has one stopping spot. Like on these ones, we had 2 stopping spots. Okay, we had 2 stopping spots on these. But on this one, we only have 1 stopping spot. And what this shows is that everything is to the right of 2. And if you think about that in an inequality and on a number line, that could be represented as the x values are all greater than or equal to -2. Okay? So same thing here. There's my stopping value for y. It's at 7. And then everything is below 7 because of this arrow. It's going to keep going, right? So we only have 1 stopping on the range as well. So this is going to be y is less than or equal to 7. And is it a function? Yes. Every input has only 1 output, or every x value has only 1 y value. If this had been an open circle, just so we're clear, we would make sure not to have equal bars on these. Okay. All right, we are going to look at this next one. Okay. So, domain, left to right. If you think about this, this is continuing to the left forever, and this is continuing to the right forever. I'm kind of exaggerating those arrows. I just want you to see that those would continue left and right forever. So we don't have any restriction on our domain. Okay, there's no restriction on the domain because everything is going to be covered because of those arrows. So when there's no restriction on your domain or your range, you say all real numbers. Okay. So what I want you to do right now is figure out the range of this graph. Go ahead. All right, so hopefully you looked at this, and even though there's arrows going down, there's not arrows going up, right? It stopped right here, and that's at 2, and then everything was below 2. So that would mean that my range is y is less than or equal to 2. Okay, and then is it a function? If I draw my lines, yes, it is. Okay. All right, 2 more. All right, left one. So anytime you have mapping or a table where you don't know, like the table, this could be linear and it could go on forever, but we don't know that, right? So these you consider to be discrete unless told otherwise, okay? Like this one, if it gave us an equation, then we would know that it actually is not discrete, okay? But we consider them to be discrete. So if it's discrete, remember, we list them, okay? And we should technically say x equals for the domain. So x equals, and I go in numerical order, remember, so this is not in numerical order. 1, 2, 4. And then this is my y. Input, output. Remember, the arrows point to the output. So y is equal to -5, 0, 2, 5. And is it a function? Nope. If you look at 4, 4's doing the no-no. So no, 4 has 2 outputs. Okay. All right. I'm going to have you guys try this last table. Find the domain, the range, and is it a function? Go ahead. All right. Let's see. So my domain, x equals, and it's nice for us, it's listed in numerical order. So we have -2, or I'm sorry, -1, 2, 5, 6, 7. Okay, and then my range, y is equal to -8, -5. So remember, even though the -5 repeats, I don't repeat it down here in my range. I just write it one time. 0, 1. And is it a function? None of the x values repeated, right? So yes, it is. All right, so that is domain and range. Make sure to do your practice on this and get help if you have any questions. See you soon.